Hey, what's going on, guys? I have a question from linear algebra to solve. The first question is find the matrix of the linear transformation txy equal to 2x minus y 3y. Justify. And since they are asking matrix of the linear transformation, I had to write in this form. It should be t1 0 1 comma 0. First I have to find that. In order to do that, I have to multiply x by 1 and y by 0. Since this in this one, this whole thing is x and this is y. So if I multiply x by this one and y by this, y by 0, since we have a y here too, therefore this one will multiply by 0 too, therefore the only thing will remain is 2 0. And the second thing I have to find is t01. t01, I have to multiply the y values by 1 and x values by 0. So if I multiply this one by 0 and this y value by 1, this thing is gonna be this y is gonna become minus 1 because I am multiplying y values by 1. This y will become minus 1 and this will become 0. Now I have found the matrix form of x and y. So let's write it as matrix of t. So matrix of t is gonna be equal to like this. So I have to write the x values in the same components like yes. So 2 and minus 1 are going to be x values, and 0 3 is going to be my, this is 3, right? This is 3 because when I multiply 1 by this negative y and this is 3 and it's going to be negative 1 3, therefore it's this 0 3. This is my final answer for A question. And the B question is asking find with justification the general formula of the linear transformation related to A is equal negative 1 1 2 0 1 3. So since we have this one here, we have to find the general formula. What I have to do is first I write this equation minus 1 1 2 0 1 3. If you see, we have three different variables, so it's going to be x y z. What I have to do is to find the general formula, I have to multiply it by those variables. So it's going to be x y z, and as you see, we have here we have uh, two rows 3 columns, so 2 by 3, and here 3 rows 1 column, 3 by 1. So we will end up with 2 by 1 thing. So it's going to be first row first column negative x 1 times y plus y and 2 times z plus 2z. So this is my first row first column, and we only have one column right here, so only two steps. So the second one is second row first column, 0 by x is 0, 1 by y is going to be y, and 3 by z is going to be 3z. And this is my general form of xyz, but I have to write it in this form. T of xyz is equal to this is like I am bringing, this is R3, right? Because three variables are here. R3 to I am 3 dimension to 2 dimension R2, and let's see what happens. So xyz, this is going to be my x value, this is going to be my y value, x minus x plus y plus 2z comma y plus 3z. So this is my final answer for this question. And the third question is asking what is the matrix of the reflection in R2 with the respect to y axis used to find used this matrix to find such a reflection for the point 1 minus 2. Okay, so since they say something is reflection in the y-axis, we have to think it as x is changing the sign. For example, this is the formula is going to be, if they say reflection on the y-axis, it's going to be minus 1, 0, 0, 1. The x is minus 1 because if something is reflection on the y-axis mean it's turning, the x is becoming negative. That's what it means. Therefore, this one is going to be negative, and they are saying that with the respect to use this matrix to find such reflection for the point 1 minus 2. So what I have to do is simply, for the second thing, I have to simply multiply this 1 minus 2 by this number and get the final answer 0, 1. So this is x, this is y, so I have to write in respect to this, x is going to be on top and y is going to be in the bottom, minus 2. And if I multiply first row first column, it's going to be minus 1, 0 times minus 2, it's going to be minus 1. And second row first column, it's going to be 0 times 0 and minus 1 times minus 2, minus 2. So this is my final answer for the second question. And the D question is asking, this is a big question, so I erase this whole. Okay, they are asking if A theta is the matrix of the linear transformation of the rotation by the angle theta, so that A theta, A minus theta equal identity. So first of all, I have to know what is the matrix of A theta. A theta, like whenever they say A theta, they are meaning this one. A theta is gonna be cos theta, sine theta, and this is gonna be minus sine theta and cos theta. This is the matrix of A theta, right? And they are saying they show that A theta A minus theta is equal to I. A theta times A minus theta is equal to I. So to show that, what I have to do is I simply multiply cos theta minus theta sine theta cos theta, and if they say A minus theta, it means this minus sign is gonna change into plus. That's the only difference. Cos theta sine theta, then here sine theta cos theta. So what I have to do is I have to simply multiply first row first column, first row second column, then second row first column, second row second column. I do it faster, so let's see. So if you multiply, it's going to be cos square theta plus sine square theta, and this is going to be cos theta sine theta. So this is first row first column, right? This is first row first column. I am doing first row second column. This is cos theta sine theta, like first row cos second column, right? Cos theta sine theta, sine minus sine theta cos theta, and the bottom one is going to be that is second row first column. So if we multiply that, it's going to be sine theta cos theta minus cos theta sine theta, and the last one is second row second column. It's going to be sine square theta plus cos square theta. Since we have all this value right here, we have to use the trigonometric things here. Trigonometry, like cos square theta plus sin square theta is 1 according to trigonometry if you study, and this one is cos theta sin theta cos theta, both are same thing. If you deduct both, it will become 0. And this is also same thing, sin theta cos theta same, cos theta sin theta both are same thing, therefore if you deduct them it will become 0. And sin square theta plus cos square theta is 1 according to trigonometric rule. And we have this one right here, this is what we call identity, therefore this is identity. We prove that the question is asking a theta matrix linear transform of the rotation by the angle theta, so that a theta a minus theta is equal to identity. That's what we have done right here. I hope you guys like this video. See you next time.